Yo, what up, everybody? Oh, 4240. Cool. Little sub count there, eh? Eh? Cool. Nice. Cool. What's going on, everybody? Hope you're having a good day so far. My name's Michael. Welcome back to the stream. We are here back in C Programming, A Modern Approach, 2nd edition by KN King. Going to be going over and keep going on these programming practice projects at the end of chapter 8. So excited to get going here. Yo, what's up, Ray? Welcome back in, dude. Appreciate you for joining me again. You're awesome, my man. Welcome back in. Big Ray. The Big Ray. Cool. Alright, we got the music going. Let's roll. Alright, everybody. So last time we finished number 7. I think we're going to be on number 8 now. So I think my goal is to do 5 today. 5 of these problems. Hey, what's going on? Just learning for ourselves, yeah. Gaining new skills and having fun doing it. So appreciate you for joining me here. Welcome back in. Welcome in. Alright, cool. Let's go ahead and get this going. So number 8. Modify programming project number 7 so that it prompts for 5 quiz grades for each of the 5 students. Then computes the total score and average score for each student, and the average score, high score, and low score for each quiz. What? Okay, hold up. So it prompts for 5 quiz grades for each of the 5 students. Okay. So we're going to take our programming project from number 7, bring it in here to number 8. All right, and then what we're going to do is we're going to change this to enter 5 grades, right? 5 quiz grades. Oh, we already have a 5 there. Okay, hold up. So enter 5 quiz grades, and the 5 will go in there. Perfect. Then compute the total score and average score for each student. Okay. So this just enters and reads. Okay. Let's try this. Okay, so what I'm going to do is int total scores, which is an array of size 5, and it's going to be equal to zeros. And then what I'm going to do is say for int I, which equals to 0, I less than rows I plus plus. Okay, so we're going to loop over every row, and then for int j equals to 0, j less than columns j plus plus. Okay, and what we're going to do here is we're going to do total scores. So total scores plus equals to matrix index. So this is going to be total scores index of I equals to, or plus equals to matrix index of I index of j, like that. So that'll handle total scores for the ith student. So that'll be the total score for the ith student. Then average score for the ith student. So int, we'll do float average score. There's 5 places. We'll set these equal to 0. Right? And then what I'll do is inside this loop as well. Okay, hold on. So after we've computed this row, we're going to compute its average. So average scores index of I will be equal to the total scores index of I divided by 5. Now what I'll do is I'll do, instead of this divided by, I'll do length, I'll just say size of total scores over size of total scores index of 0. So we'll compute the average scores for the ith student after we compute the total scores for the whole row. So this is summing the entire row for the ith student. And then after that summation is done for that row, we are going to take an average by taking the total score for that ith student and dividing it by the length of total scores. Or this wouldn't be total scores, this would be the length of I'm wondering, can we just use, because no, so this just needs to be, that's not the right way to compound. That's not, it's the right number, but it's not the right value, like representation of the number that we're wanting. We're wanting just a 5 here, basically, for the average scores taken. Or we want to do the length. Actually, no. Let's bring this back. We want to do size of matrix index 0. Size of matrix index 0, index 0. So that'll take the size of the first row of the matrix and of the 2 by 2 matrix, and then take the size of the element within the matrix to give us the size of that row, or the length of the row. Wait, hold on. Right. Hey, Zoro, how's it going, dude? Do we still do leak code? No, not really. I'll do some problems every now and then on my own, but I don't really like doing it on stream. It's just, I spend too much time kind of thinking through stuff It burns a lot of time I could be spending doing projects, reading books, and whatnot. I don't know. It's not very efficient stream material in my opinion. I don't really like it. Some people like it though, so good on you if you do. It's just not for me. I mean, I do them though sometimes, but I just don't like streaming it. So that's the average scores. And the average score, high score, and low score for each quiz. Ah, okay. So then we're going to say so then we want to do the average score, high score, and low score for each quiz. So the quizzes are going to be indicated by J. Right, so we're going to do like this. We're going to do quiz totals of 5 spaces is equal to an empty array of 0. We'll have this be an integer array. We're going to compute quiz totals at index j plus equals to matrix index I, index j. So this will compute for that column, only that moving column value within quiz totals, the associated value, rather than the outward student, right? These represent students, whereas these represent quizzes. Right. So then we want to compute the average score for the quiz. Okay, so where would we do that at? After we've computed, we might have to do another loop over the average scores. Because, or the quiz totals, I mean. So in quiz totals, we're summing up the columns into an array. I wonder if, I know the scope of this for loop ends here, but will that j value be maintained in memory? Like j is set to, at the end of this loop, j is set to 4, right? So could we set j, or we want it to do when j is. Okay, we'll say int high quiz, which is equal to 0. Yeah, an int low quiz. So we have int high quiz and low quiz. And so right here, we'll do an evaluation. We'll say if high quiz What if we set these both equal to 0? Would we want to do that? I'm not really sure. So if the high quiz, or if the high score in most of each quiz. Oh, okay. Sorry. Int high quiz is quizzes like this. And int low quiz. Right. So we have int quiz totals. So quiz totals is being summed here. Okay, so if quiz, no, so if, so we want to say, what do we want to say here? Let's think this through. Okay, so we are accessing the J, which is the quizzes right now. We're inside the quiz loop, looping over all the quizzes. So J is moving forward while I is stuck until we get out of this. So J is moving forward to the end of the quizzes. So what we're going to do is say if matrix index I and J, if matrix index I index J is greater than high quiz index of J, yeah. So if matrix index I index J is greater than high quiz index J, then what we're going to do is set high quiz index of J equal to matrix index of I index of J, right? If matrix index I index J is less than low quiz index J, then we're going to set low quiz index J equal to the matrix index I index of J. So if this number if the number that we're evaluating is greater than the current highest recorded value in the index for the high quizzes, for the jth quiz, then we're going to replace it with high quiz index J equal to matrix of the value we're on. Same thing, if the value we're evaluating is lower than the jth quiz in the associated low quizzes, then we're going to set the low quiz of the jth quiz to the matrix index I index J. So we'll say average student scores, average total student scores. Like that. And then what we'll say, we have int total total quiz scores, size of 5. I guess this is going to be size of the columns. This is going to be size of columns. Columns. Oh, I'm already doing quiz totals here. Yeah, okay, good. So this will be int average quiz scores. So average quiz scores. So after we've computed this, we need to, the average quiz scores has to be computed, I believe, outside of the loop. Because entirely, we need to evaluate over all of the students over all of the quizzes. So now we need to say for int I equals to 0, while I is less than the columns I plus plus. Open this up. We're going to go to average quiz scores. Int of I is equal to the quiz totals int of I divided by this. Same thing, right? Hey AJ, how's it going, dude? Welcome back, man. Appreciate you being here and joining me again. Okay, so the problem asks us to prompt for 5 quiz grades for 5 students. So we're going to ask 5 students for 5 quiz grades, so a total of 25 grades, or a 5 by 5 multidimensional matrix, 2D matrix. We are going to compute total score and average score for each student. Okay? So for the ith student, right, every row represents a student, and the columns within that row represent their quiz scores. So the ith student, their quiz score will be increased by the matrix value for the ith student for the increasing quizzes of J. Got you. Total, okay, now average student scores, after we've computed all of that student's score, right, summed into total scores, that goes there. So total student scores, index of the ith student total score gets increased, right? So the average, so the ith student, after we've computed all of that ith student's summed quiz scores, we're going to generate the average score based on the total, that student's total scores summed and the length of the row, or the amount of columns, right? Which I guess we could just do as columns. This one would be size of average quiz scores, size of average quiz scores index of 0 to be more precise. This one can be columns because we know that the quiz's amount equals the amount of columns. So then we're also asked to compute the average score for each quiz. So what I did is I computed a total quiz scores, right? Quiz totals, right, of 5 spaces. And what I do is I set the jth quiz equal to the quiz we're on, right? Plus equal, right? So the j's will increase for the ith student. Then we need to evaluate for the high quiz and low quiz. So if the number we're on, the quiz we're on, is greater than the high quiz at index j, which is our tracker for the high quizzes, then we're going to set the high quiz to that. Now I guess I could do like a high quiz index, maybe would be a more efficient way, and just do a single integer and then index into the array using the high quiz integer. Let me do that actually. High quiz index is going to equal to 0 to start. Right, and then we're also going to set this equal to 0 for low quiz index. Cool. So what I'm going to do is oh, whatever. Hold on. Never mind. I'm just going to leave it. Who cares? Whatever. And then we do the same thing for the low quiz. Okay. And then we're asked to find the average quiz scores. So what I do is I loop through the quiz totals for the ith quiz and compute the average of that based on 5 quizzes. Oh, no, it's just quiz totals. No, this was we want to do the number of quizzes, which is columns. So I think it'd be fine just to say columns, like we have before. Hey, Muna, welcome back, dude. Welcome back, welcome back. It's awesome to hear from you. Okay, let's try this. Or hold on, let's say, now let's do printf. We'll say we'll say okay, we'll do this. I'm already looping here, so I might as well take advantage. Well, I'm gonna have to loop again. Ugh, well, that's kind of sucks to do the print. Right. So I less than the columns. So what I'm going to do is print out printf average quiz score say this, then we'll say here printf quiz I think I have average scores. Let's do float. We'll cast the quiz scores total. We'll do the same thing here. Woo! We got it. Nice. That feels good that we were able to see that, hopefully. Well, I don't think we might need to do we have to do one or the other? Or just doing one float call, one float conversion suffice? Does float have higher? It might, okay, we'll keep it. And then let's say average quiz score is going to be average quiz scores index of I. Then we'll do a \n. And then what we'll do, okay, hold on. We'll do this. We'll do results. We'll say quiz 1. We'll do something like this. Quiz I. Right, and then we'll do a \n. We'll do a printf. We'll say average score is equal to and we'll insert into here the average quiz score. We'll just say average was equal to quiz scores index of I. We'll then call print, no, we'll just duplicate this down. We'll say that the high was equal to high quiz index of I, and the low is equal to low quiz index of I. And then we have average quiz scores, which we already got, and then quiz scores total. So per quiz results, we'll copy this down, delete this. This will be per student results. So student I into here, right? And then we'll do the average would be average student scores index I. There's no high or low for the student, so we're not computing that. But then we have so we're printing out the high, low, then the average, and total and the average. Okay, I think that's it. Oh, we need some backslash n's here. Okay, so should we try it? I don't know, we'll find out. GCC-O. Variable size object may not be initialized. Variable size object may not be initialized. Why? Let's go to my notes. Thought we could do that. You can't initialize them all to 0 if you do a variable length array. Does it do it by default? Okay. Um, 1, 2, 3, 4, 5, or 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. Oh gosh. Dang it. Per quiz results. So the low okay, let's see what's going on here. So we entered our grades. Quiz 0. Average, wrong. High is obviously wrong. Low is correct. Quiz 1. So we need to do quiz. All right, let's try it again. Okay, per quiz results, quiz 1. Okay, we're not doing it. This is not right. Okay, the per student average is correct. Okay, that's good. So the per quiz is what's wrong here. Okay, so we had, and okay. So if the value that we're on evaluating, right? If the quiz that we're evaluating is higher, oh well, we're does variable length array in C auto to all 0? No. Oh, we have to initialize. Okay. Interesting. So I have to, if I do something like this, so I need to, if calls equals to 5, this wouldn't set all 5 to 0. This is garbage. That's why we're seeing this. Okay, that makes sense. Okay, good. So then what do we need to do? We'd have to do another loop or mem set. This only works for fixed size arrays. This, like, okay, interesting. It's kind of, that's kind of weird. So I'm not going to do another loop. We'll just go like this and do that, I guess. Whatever. Okay, let's try it again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Per quiz results. Quiz 1. Average was 1. Perfect. Average 2, average 3, average 4, 5. High, low. High of 1, low of 0. Oh, because I set the quiz low. Okay, so hold on. All right. Interesting. Okay, so it's giving us a low of zeros because technically that is the low because we initialized zeros up front. And if the low is never going to get below that. Right, if we don't put in a 0 for a score. So quiz 1 should have a high of 1, low of 1. But it doesn't. High of 2, low of 2, high of 3, low. Okay, so everything else is right but that. Okay, so we've initialized these to 0. Okay, hold on. Let me read some chats now. Hey Mike, just checking in. How you like working with a typed and compiled language compared to Python? I don't know. I don't really like. I don't know. Like I don't find this really that like too difficult in terms of it. Kind of just makes sense to be a little bit more clear spoken. Like it's just like talking in full sentences versus talking in slang. Like both points get the point, and like I'm not like a kid anymore, so it's not really like annoying to do. It's kind of like honestly talking in full sentences kind of as like an adult feels a little bit more preferred, right? It's kind of I don't know, maybe like with age you kind of come back to you kind of start liking C. um do you find it hard to switch between languages? just between Python and C, it's not too different. Just a little bit of syntax stuff. Python's very, very simple in its syntax, so it's not really too hard to kind of switch my mind. The only thing I really kind of mess up is the print and printf. I get those. I always jumble those. Have you been to university? Yeah, I have a degree in human biology and a minor in chemistry. I graduated back in 2021. I feel like at this point you at least have the knowledge of a second year CS student, not that this is a good measure of programming knowledge. That's what some people had told me. They said kind of like second year ish. Yeah, this is KNR. Oh no, this isn't KNR. This is sorry. This is C Programming: A Modern Approach by K.N. King. Do I turn off LSP intentionally? Can you? Sorry, I'm a noob. Can you? What LSP? Give me a little breakdown. Sorry. Lisp. Okay, cool. Let's keep rolling. If you guys are here and you could leave a like on the stream, I'd really appreciate it. Thanks so much for being here and chatting with me, everybody. You guys are awesome. What's up, Silva? Welcome back, dude. Okay, so everything else works except for the fact that we've initialized high quiz and low quiz. Well, you can't have a negative value. So let's set it to -1. No. No, so the high quiz, you will always have a value, whether you get a 0 that is greater than -1. So we will always override -1s. Low quiz, however, you can never have a value that is higher than 100. So I think if we do 101 for all the values within low quiz, that'll work out how we want. If that's the limit for what you can score, right, between 0 and 100, assuming. Oh gosh. Really? High is 1, low is 1. Good. High is 2, low is 0. So it craps out after that. Oh, because it's filled in for everything else. This is kind of annoying, but I mean, I think this will definitely do it. I don't know if this is like the most, C-thonic way to do it. There we go. Okay, I just need to do one thing here and do row +1. Okay, so that's my answer for this one. That one was long. Holy crap. Let's get some feedback on this guy. So this is my answer for this one. I'll zoom out so you guys can see it. It might be a little bit hard to see, but this is my full answer here. So what we're doing is we establish rows and columns and make a matrix that's two-dimensional based on that, or a 2D array. We then loop through and gather 5 quiz grades and save each of those within the rows or each of the positions of the matrix. So 25 quiz grades total, 5 each row. We then establish total scores and average scores at zero, and quiz totals as 0. We do quiz highs as -1 and quiz lows as 101, assuming that you can only score between a 0 and a 100. We then have also average quiz scores of size columns. This one, oh, because I'm not actually accessing this anywhere and doing a conditional evaluation before actually saving it. I'm doing an override on everything. I'm not doing any conditional logic before actually doing any access and any save. Okay. Cool. All right, that's my answer for this one. Wait. Yeah, why did I delete that? What the heck happened? Okay, they were fine. Okay, I'm gonna take this. Let's get some feedback here. LSP is the completion thing. Use. No, I don't have any like completion thing on. I don't know. I just write. I don't know. I just write. Whatever. Just type it out. Yeah, unfortunately, we haven't learned about the function memset in the book yet. I don't think we learned about. No. We did learn about const though. Right. They should be modified. I mean, we could go like constant array, but whatever. Okay, so let's take this. Let's get some feedback here. Okay. Could I get some feedback on my code? I think things are okay, or at least I got the right outputs for 5 quizzes, each with score 1, 2, 3, 4, and 5, and then I'll give it my, oh, shoot. Okay. This is all correct C, and for class assignment, this would be absolutely a pass. You're reasoning about the data correctly, your loops are structured cleanly, and your results are being correct. The test case is a good sign. Well, you did well. Correct use of a 2D variable length array. This is valid C99. You can use it consistently with the rows, matrix, rows, columns. Initialization discipline. You correctly initialize all arrays that needed it. This avoids undefined behavior where many students fail. Your sentinel values for high quiz, low quiz are reasonable given quizzes are 0 to 100. Loop logic is correct. This core logic is clean and correct. And min-max check exactly how they should be written. The casting is done correctly. Let's go. We caught that. Things to tighten up. So we do mix some VLAs and fixed arrays here. But we can't set those all to 0. So we haven't learned about memset though. Should divide by rows, not columns. For students, sorry, yeah, rows. Same number in this circumstance, but if someone were to change that, it wouldn't be, because this is average student score, which is divided by the number of rows. Yeah, that would make sense. Nice. All right, I'm happy with that. That's good. Happy with that. People ask this question all the time. How much? I've gotten this question like 4 streams in a row. I don't know why people ask it. This must be a pretty interesting. I don't know. But how much RAM do I have? I have 32 gigabytes. No, 36 gigabytes of RAM. Would they come in the MacBook? Yeah, it's 36. It's not 32. Yeah, I have the. Let me see. Let me grab my. Can I go to like about this schmack? Yeah, Apple M3 Pro, 36 gigabytes. Yeah, the 1 terabyte. Doesn't tell me my exact chip, but it's not the base. It's not the it's not the Pro base, but it's the Pro upgraded cores for the graphics and stuff, but not the Max. So it's, oh my gosh, Apple killing me. SSLO says, wouldn't the bracket 0 bracket initialize all elements to 0? Why didn't you use an memset? I think he's referring to why we did, why we changed these. Well, because I was using columns. Okay, so let's do, this is row. This is also rows. But you can't do this. This doesn't work, right? Oh, it is. It does work. No, you have to do the 5. But saying int quiz totals columns equals to array of zeros is invalid. That sucks. I feel like that'd be really nice. So this is invalid. That's why I had it as 5 here. So I'd have to loop through and fill zeros for all of those, which I guess I could do with 1 loop or something. But I don't know. It's kind of like overkill. Oh, nice. I ordered 24 gigabytes on the base Pro refurbished. Oh, nice. Yeah, it's pretty great. I have OBS going. I have YouTube going, code going that I'm running stuff with and doing like, I'm doing full stack dev sometimes. I've got my, books open. I've got music going. I've got GPT going. I've got, video camera going. I've got it all. And my MacBook is cold. No fans are on, which is the crazy part. I'm streaming 4K. I'm using two external monitors and my MacBook, OBS, YouTube, VS Code, GPT, I mean, Bluetooth, multiple Bluetooth devices, tons of stuff. I don't know if that even matters. But and my MacBook doesn't have a single fan on, and it's cold. These new MacBooks they're killer, dude. They're top of the line, man. I really like them. Yeah, probably should look into more. I'm hoping the book kind of gets into more about different compilers or stuff. Maybe we'll have to do like a deep dive on compilers. What's offered out there. Yeah, the book hasn't given us the memset function yet, so we're kind of keeping by the book, but people are telling us we could have used that here. Would have been helpful. Um, wait a minute, where's Tim? Yeah, Tim ain't in here. Where's Tim at? Where the Tim at? We need Tiny Tim. Initializing VLAs with the curly brace zero curly would be problematic in some C standards, I think. The Apple icon in the top left will show you about this. Oh, yeah. Yeah, I think it'll be a while before. Yeah, the only thing is if the M6 MacBook Pro is teased to be really, really, really cool. It's supposed to have like built-in, wireless capability, which would be so awesome, right? Just wireless built-in. Like I'll add it to the plan. I don't care. I'll pay it. Wireless to the plan on the laptop. Um, then I don't even need mobile hotspot anymore. That's gone, completely gone. I don't even have hotspot anyway, so I would get a completely new feature. 4K webcam. Um, what were some of the other features? There were some crazy features with the M6 MacBook Pro. Let's look it up. M6 MacBook Pro feature list. Major redesign, several key features. Oh, OLED display. OLED display, a punch hole camera replacing the notch. The notch, I think it's fine. I don't really care. People whine about this notch. There's like barely any bezels on this thing. Touchscreen support. Eh. No one's gonna be touching your MacBook screen. I think if you get your greasy hands off the screen. 5G cellular. Boom. Game changer. 2 nanometer silicon chip. Could potentially exceed $3,000 though. Oof. Ooh. Bro, I gotta work like 2 weeks plus to pay for one MacBook. That's crazy. Yeah, touchscreen, chipset, connectivity, camera. The camera is honestly if the camera's better because I use the webcam for streaming, it might be worth it. But the hotspot's big too. OLED display. Okay. But apparently they have reasons for them. So also, do you think there's a good job market for Android? I'm not sure. No idea. I don't know anything about Android devs. Oh, he's probably asking someone else. That's crazy. I have nothing but Chrome tabs open. To be honest, a lot of them in my ThinkPad is warm. Yeah, no, dude. My MacBook, the cool anodized whatever metal, it's chilled to the touch right now. Not even a single fan on. I've only got my MacBook warm, maybe slightly warm like one time, like editing some video, like rendering out some videos without having it like plugged in, like just doing like some lap editing and coding at the same time or something like that. But that's about it. Barely got it like any warm. The only thing I'll go against the MacBook and say that it's really annoying is he just it's so the only thing that's annoying is you got to pay for the Apple Care because you're so scared to bring it anywhere because you're so scared it's gonna like break. Like it's built sturdy, yeah, but like one little drop, one little thing, and it's dented. Like it's and could be broken. The screen could be broken. Like it's just like one little hit on the side. It's like it's toast. So the only thing is you that's where they get you is you have to shill out the Apple Care just for like peace of mind. Yeah, we I've been using GCC here. That's what the book's been kind of teaching us. When I bought my MacBook Pro, I got the last Intel one. Bruh. Okay, cooked. Sorry, man. Interesting. Yeah, we probably should get in the habit of using the more universal underscore T types, like we learned about in chapter 7, to be more fluid than using some of these. It's kind of annoying how different operating systems interpret these differently. Like it'd be just like just take the int, just take the float. Like don't make me have to do int 34 6t bty. It's frustrating. Lots of chats here. Thank you guys for chatting with me here. You guys are awesome. Sorry if I'm not coding right now. I'm just catching up on chats and I like reading with you guys. I have a desktop PC. I have a 5070 down here. NVIDIA GeForce Founders Edition. I have a 5070 and a AMD, a pretty hefty processor as well. I picked that up about 6 months ago. I'm just building it under. I get Apple Care. I'm just gonna hope nothing happens. Yeah, you should be. I mean, just be careful, right? But I like that peace of mind in case something happens. I've had like my phone just like just break, like just sitting there doing nothing. Like I was just sitting there scrolling on my phone, and my Wi-Fi card in my phone just stopped working, just got fried out of nowhere, just sitting there. And so I got lucky with some of the cares before, and with AirPods too. I've gotten lucky with the Apple Care. So I don't know. Okay. Okay, cool. Let's keep going. That was number 8. That one was tough. That one was a long one. Okay, number 9. Well, my goal was to get 5 of these done tonight, but that might not happen because I'm not going to stay up late tonight. We've been talking and having fun, though, so it's okay. I like hanging with y'all. It's fun. Let me open up the Streamlabs in case there was any subs. Gotta give you a shout out, boys. Bang Nidru, thanks so much for subscribing tonight. Appreciate you. You the man, you the boss. Okay, so that was number 8. Number 9 here. Let's get rolling. Let's see what we can do. Number 9 says, write a program that generates a, quote, random walk across a 10 by 10 array. The array will contain characters, all periods initially. The program must randomly walk from element to element, always going up, down, left, or right by one element. The elements visited by the program will be labeled with the letters A through Z in the order visited. Here's an example of the desired output. Hint: use the srand and rand functions. Okay, yeah, that's right. So we need to go visit our notes here for random functions. Here we go. So srand gives us a random number based upon a seeded value. A function from the standard library that initializes seeds a random number generator given a seed value. You can pass the return of time null as a unique seed. And then the rand function is in the standard library header that generates a pseudo-random integer each time it's called. The modulo operator can be applied to limit the ranges of values. For example, rand modulo by some length, which produces a value suitable for indexing into an array of length. Okay. Okay, sweet. So this actually doesn't seem... Okay. So let's go ahead and include the standardu.h header file. We'll go int main void. We'll open this up. Okay, so then I guess let's get in the habit of using some define. Is it define or is it declare? Maybe define. Let's define size to be 10. And that's fine. Okay, so what we want to do is we're going to create a integer matrix, which is going to be of size by size. Right. And then we're going to say for right, so now we need to initialize all of these values. So we have to do for int I, which equals to 0, I less than size I plus. And then I'm going to take this for loop and just copy it here. We're going to set matrix index of I, index of j equal to quote period. Oh, this is a char array. Okay. Okay. Next, we want to, okay, we're going to say, we're also going to do an int options, or we'll say directions, index of size 4, and I guess we'll set this equal to 1, 2, 3, and 4 as such. Maybe I'll use chars, actually. Char direction array of size 4 is equal to an array. I'm going to say up, down, left, and right. Should I maybe, maybe we'll being super nitpicky, but we'll do north, east, south, west. Okay. So we initialize all of them to 0, or to that. Okay, so what we need to do is we need to randomly pick a number so we need to establish 26 values. So let's actually do this. Let's go ahead and get the ASCII value for capital Z. Let's get an ASCII image or ASCII chart for capital Z. And then what we'll do is we'll decrement Z down until we reach 65. Which will be nice. Where are you? Here we go. 90. So I'm going to say is ch, we're going to say char ch is equal to quote 90. I guess we could say just z here. We don't even need that. I don't know why I do that. We can just say z, because then we can decrement the z down because it's an integer. Okay, cool. So we're gonna say while char is greater than or equal to capital A, we're going to enter this loop, and we're going to generate. We're going to say we're going to generate a random number. So random is equal to random number. So we'll say int random number is equal to our rand function. Do you put null inside of here? No. So we're going to generate a random number. And then what we're going to do is we're going to I guess we'll say index, and we'll do a random number modulo by the size of direction divided by size of direction index of 0. So that'd give us the length of the direction array. We could say 4, but whatever, we'll use that to be safe. So we have int index equals to this. Or say, yeah, direction index. Okay. Then we're going to say, so now that we have the direction, we're going to want to decide if the direction will go out of bounds or that it's already on a value. If all 4 are blocked, the program must terminate. Okay. So, if matrix index, so what we'll first try okay, so let's actually do a switch statement. We'll do switch on the direction index direction index. We'll open this up. We'll add a case of quote north, right? Do you do this? We used a switch case earlier. Hold on. Yeah, case goes there. Okay. So we're gonna do this. So case of north, what we're going to do is say if matrix, so this means we need to move up in rows, so we have to move I upward. So if but we're not actually, oh shoot, we're not actually do we start at a random place or do we start at 0, 0? Oh, we start up at top left, it looks like. Which is 0, 0. Okay. So I guess what we'll do is we set int I equals to 0 and j equals to 0 as well. I guess I'll say row and column here to make it a little bit easier. So we'll start at 0, 0. So we're going to get a direction. Now right away we need to, if matrix index row index column, so we first want to, so this is north actually. So this would be if row plus 1 is greater than, if row plus 1 is greater than the size, then this is an error. I guess we'll say, or what else would cause us to break? If the value is already taken. So if the matrix index of row index of column is not equal to, no, if it is equal to, oh yeah, not equal to, quote, period. So if the row, if we increase the row and that is greater than the size allowed, or the matrix that the value that we're trying to save on no, row plus 1, right? So this will short circuit if this one fails. And so wait. Maybe we'll do the successful. So if row plus 1 is less than the size and row plus 1 index column is equal to a period, then we're going to go ahead and save the value. So this would need to be an and. We're going to save the value of matrix index row plus 1 index of column, right? So then what we're going to do is set row equal to row plus 1. We'll just say row plus equal 1. We'll do this. Okay, so if we want to go north, we have to first check to make sure that row plus 1 is within the size allowed. Now, can it be equal to the 10? No, because it's 0 through 9. So it has to be 1 less than the size. Perfect. So if the row is less than the size, we can do this. And if it's also equal to a period, we can do this. We can override the row, that value, and increase the row. If that's not the case, say else sorry, my brain's slowing down here. We've been working all day. Let me read some chats here. Okay, and the units can times also. We're doing number 9 right now. Paul, thanks for coming in, dude. Thanks for the sub. Who is that? Or no, thanks for following. Expertise. I like that name. Okay, so else, if this is the case, if these aren't successful, we need to break out of this switch statement. So else break. And then what happens is we need to set the character, right? Equal to character and then character less equal by 1. So now we're going to go ahead and copy this down for north. We'll do west. This will be row, or sorry, we'll do south. This will be row -1 and size less than there. Matrix row less than 1 is equal to a period, then we'll decrease the row, save that matrix at that value for whatever character we're currently on, reduce the character down for the next pass, and then move forward. So I think we also have to break here. So then if we do case of east, this would be if column plus 1, or well, sorry, well, this is in minus, so we'll do west. Now this is going to be row is the same, stays there. Column less than 1. Column, and the character reduces down. Then if we do east, for row plus 1 is greater than the size, or no, sorry, this is column plus 1, column plus 1, column plus equals 1, character reduces down, else break. Hey, Jimmy. Thanks, I like the compliment. Thank you, I appreciate you, my boy. Jimmy's always coming up clutch with the compliments. Jimmy riding that boats and Jimmys. Okay, so what'll happen is we will continually loop this outer loop here until we reach a value. But the thing is if, oh, but what about, so if none of these cases can be met, so case E, and that can't be met. So we're not going to break. Okay, so I think what we're going to do is we try north. Right? We try south. We try west. So we'll go in a clockwise order though. So we'll do north, east, south, west, right? So we'll fall through if we don't hit north. I'm trying to figure out how you would do the thing for if you have all 4 sides taken up. Right? If you have all 4 sides taken up. The element visited by the program will be labeled. looking for... Yeah, it's supposed to end, right? But I'm gonna take it, I'm gonna ask a question. I am trying to compute a random walk through a matrix, assigning letters A, through Z. So we need to start on A, sorry, my bad, on blanks, and stopping if all sides are taken. I'm getting tripped up on the all sides taken part. There's a comma that needs to be there. I need to include the standard library. And you must seed once. Okay. So we did need to seed in order to generate the same. Returns a function? Must also ensure that it's greater than or equal to 0. So we need to have this be B. This goes to Z. Because we're going to place matrix row column. Equal to quote A to start. Huh. They kind of build on each other. They ask you to go back through and build on some of the pre in text examples and stuff. But they don't really interact one to another. But they've gone yeah, I don't know. Kind of, I guess. Would the logic after the switch the switch statement tries to make one random. If no moves are possible, the switch will keep failing. Each iteration of loop should be check if at least one move is possible. If not, break out of the loop. Pick a random direction. Try a move once. Okay. So what we'll say is this: int blocked equals to 1. If row plus 1 less than size, right, and row is greater than or equal, no, matrix, it's basically this. So this will be else blocked. No, yeah, so we do basically, okay, we're gonna basically take all of these similarly. If this, then if this is greater than size, less than size, then block. Equals to 0. Right, so if we do this, and last one here. Okay, so right? If row less than size, I'm a little bit confused. I'm trying to get some clarity on the logic here for this section. Got the right structure. Just in some semicolons, it says, like usual. Here. Oops. So these characters need a plus equal. And the character will be less than or equal to z, as b is smaller than z. Yes. If blocked. So if we're blocked, though, at the end of this, right? Right, if we're blocked, then we have to break because we can't. So when you enter in, you evaluate if you're blocked. If you're blocked, then you have to break. If you're not blocked anywhere, then you know you can make a move. So you need to keep randomly circling this loop until you hit a movement here. North and south. So the row has to be greater than 0 because it's south. We say if the row is greater than 0 and matrix. So what is this one trying to move? So if the row is greater than 0 and we're trying to move row, why would it be row greater than 0? And then row minus 1. So if we say if the row is greater than 0 and the move down Oh, because we don't want to move into the negative, right? So you can go down to 0, but you don't want to be greater than 0. Yeah, that makes sense. So then we need a similar concept for the column. So it'd be if column is greater than 0 and matrix of column less than 1. Right. But then we can, so then we're going to have this guy. So this would be row. So this is for the south move. This is for the north move. Right. And then this is for the rightward move. This is for the leftward move. And this would go away. Sorry. I don't know. I'm getting confused on this one. Hopefully I'm on the right track here. So we set blocked is equal to true, right? If we're greater than 0, meaning we can land on 0 index, and we can move downward to that 0 index, then we're going to say that blocked is, we have moves to make. Same thing if the row is 1 shy of the size, and we can move up to that value, then we're going to say blocked is 0, and then vice versa for this one here. So this might be all of it. Currently on chapter 12, Schwab. Nice, dude. You're ahead of the game here. That's awesome. How have you liked it so far? It's less than size minus 1. Why does it, how is that different? Like this versus column minus 1. How is that any different? We can have a break after each else statement. Yeah, this one's tough. These ones are definitely getting longer and longer, that's for sure. Oh. I guess moving north on a matrix is down. In a matrix, north is usually down in memory. Oh. So then how does this look here? Row plus 1 equals down. Fixed direction movement recommended. Change your switch to row less equals less here. So we're going to move downward. East. Row less than size -1. Column plus going south. Oh, this is so frustrating. Char A. While Z. Direction. Break. Here. So just do direction index. Just do the direction index. Case of 0. Row greater than 0, matrix less greater. This is 1. Column less than size -1. Matrix row column +1. Yeah. Column ++. Matrix row is character. Because you don't need these inner breaks either. Okay. So in the case of 2, row size less than 1 and row +1, row ++. Greater than 0. And matrix index column less than 1. This is really, okay, so interesting. getting some feedback, trying to kind of learn from some example here. So I spent a little bit of time on it now and wanted to kind of see what the flow looks like here. This is 3. Okay, so then what we'll do is now we'll go and take this for loop here. At the end of this, I'll call printf to quote %d quote matrix index I index j. And then at the end of every row call, we're going to call printf \n here. Okay. So in the case of north, we want to make sure that we can go downward, right? North is down in this case. 1 means that we're trying to increase the column to the right 1 value. So it means that the column has to be less than the size minus 1, which is the same thing as column, I thought, less than 1. Size 10 minus 1 is 9. Column has to be less than or equal to 9. No, not column less than 1. Yeah. Has to be just less than size minus 1, 9. In order for us to make that move, yeah. Okay, so then I think if we run this guy here, always, 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 always. Oh, characters. Oh, this is kind of fun. Look at all those random walks. Nice. Look at that. Cool. So it actually it's pretty hard for it to get all the way through A B C D F G H I J K L M N P Q R S U V. There we go. Got to Z there. Not there. Got there. Not there. Got it there. Got it there. There. Well, sometimes it happens. Sometimes it doesn't. Okay. Cool. All right. That was that one. That one was a little bit tricky. That one was tougher for sure. This part I needed help on for sure to understand the blocked logic. So just use flags and then use your logic to basically indicate whether you have to move past that flag for the second portion of the logic. Okay. Cool. Let's just do number 10 really quickly and then we'll be done for today. Yeah? Number 10 says, from programming project number 8 in chapter 5, this guy. Oh, we've been through this before. Let's go to 10. Modify so that the departure times are stored in an array and the arrival times are stored in a second array. The end times are integers representing the number of minutes, seconds. Oh boy, I'm not doing this one tonight. We'll do this one tomorrow. It's already 9:40 here. We really spent 2 hours doing two problems. Ah, dude, I don't know. Like, let me know if you guys are still here with me. Like, is it? I don't know. I feel a little bit discouraged, like not completing a lot of like problems in terms of like count within like two problems in 2 hours just seems so brutal. Like it seems kind of it just kind of seems discouraging based on the numbers. Like, oh, we've been doing all this and we still can only complete two problems in 2 hours. It's like, bro. Or are these programming projects supposed to potentially take up to like an hour each? Like, is it supposed to be a harder task? Like, or like I'm trying to gain some perspective about if we're on the right track here. If we're, I mean, it might just be like insecurities talking and just me just being annoying. But like, yeah, right. Knowledge is better than problem count. Time depends on the problem. I guess so. Like maybe like these like moments where we're really like racking our brain, going back and forth from example to what we're writing to feedback to writing to feedback, like going back and forth trying to deduce like what is the correct approach based on some I don't know. AJ, that kind of seems these problems just take a while for seems like what little gain. That's a problem. That's a pretty like honestly like a wise way of putting it, or like a high level way of putting it. I think it's a good descriptor. It's a lot of like of work for like very little gain. Um, right. You're just doing like a simple. It's a relatively simple task, but it requires upwards of like 60 lines of logic in order to fulfill this relatively simple like task. I think that's why the task feels so simple, but yeah, we're still having to write 50 lines worth of logic in order to go through it. Is that kind of what everybody else is feeling like? Who was the boy that was in here? That Schwab. What do you think? If you're still in here, if you guys could leave a like on the stream before you head out for tonight, I really appreciate it. My name is Michael. I really appreciate everybody being here. I got a Discord link down below in the description with all of my resources for my entire learning journey so far in there for free. Um, I stream every single day, almost me teaching myself computer science and programming. We've been working through the C Programming, a Modern Approach by K.N. King, reading the chapters live on the stream and completing the post-chapter problems, the exercises, and practice projects. We've been building live full stack projects such as Bitter Linen and Pocket Farm live on the channel. So make sure you tune in for the occasional stream when we work on those. Um, but yeah, I think I'm gonna be head out for today. We did a 2 hour and 10 minute stream today. I already did a, 8.5 hour workday. So your boy is cooked. We put in 10, 12 hours every single day. So that's why I tell myself I'm gonna do a lot of work on the weekends and grind, but 10 to 12 hour days, 5 days a week is pretty it's pretty grueling on your boys. Um, anyways, I appreciate you guys being here and hanging out. I'm gonna go ahead and head out for tonight. Grab make myself a peanut butter and jelly, pet my dog on the stomach, and watch an episode of The Office or something before I go to bed. um, let's see here. Someone said, "Oh, thanks, Ray. Appreciate you, my guy. Ray's the best." I'm working on a problem that lasted months. These problems just take a while for me. Maybe because you are new to both C and current concepts. Faster at it. Good for solidifying concepts, but you'd also be solidifying those concepts while using more fundamental concepts. More widely used, like Malik. I never count my lines. Are you done for the day? Yeah, well, I'm in looking in Cali here. Unfortunately. All right, guys. I'll see you later. Talk to you tomorrow. Talk to me on Discord if you have any questions. Yeah, talk to me about your job search. Let me know what you're applying, what's out there. Um, yeah. Anywho, guys, I'm bouncing tonight. Peace out, guys. Have a good night.